Thank you, everyone, for joining us today. My name is Kat. I'm with the International Studies Association. We are located in outside the University of Connecticut. For those who are curious, today we have with us Patrick Mello, who is an assistant professor of international security at Vrije Universiteit Amsterdam, and we are going to be talking about quantitative comparative analysis. So I'm going to hand it over to you, Patrick.
Yeah, thank you so much, Kat. Thanks to ISA for having this event. My name is Patrick Mello. I'm going to be talking about qualitative comparative analysis for the next roughly 90 minutes or so. We'll see how this goes. And at the end, there's also the opportunity to address questions. So today I will run you through qualitative comparative analysis, the method of QCA, in a very condensed format, which means that there are also some aspects that I can't address. But I try to give you a more or less comprehensive impression of what QCA is, how it is applied, also with an empirical illustration, and what things you need to look out for when you are thinking about your own QCA study. So after a brief introduction, I speak a bit about QCA publications, how the method has evolved methodologically, also in terms of empirical applications. I provide you with one empirical illustration to run you through one QCA study. Then I provide a bit of the basics on QCA. You need to learn about set theory. QCA is a set theoretic approach, and I'll tell you what that means and how that differs from other methods that you may know. Before speaking about calibrating sets, which is an important aspect. In order to really do a QCA, we need to do calibration, and I'll tell you what that is. And yeah, the most important section then is about set theoretic analysis. This is where everything is put together, and we do a QCA, and you learn how to do a QCA analysis involving necessary conditions, sufficient conditions, and the like, before wrapping up and then also addressing questions you may have. So, by way of an introduction, if I wanted to summarize what QCA is, then I think Charles Reagan's quote to saying that the QCA is a case-based method for comparing wholes as configurations of parts really sums it up nicely, also in a non-technical way. So QCA at heart is a comparative method that you could use whenever you're interested in configurations, combinations of factors. So it's not about one factor correlating with another, one variable having an effect on another one, but rather about combinations of factors, combinations of conditions that you think relate to some outcome, as it's called in QCA language. And this will be something that you can analyze with QCA. The method was introduced in 1987 by Charles Reagan in his book, The Comparative Method. There's a second edition as well. And Reagan then developed the method over several decades, starting in 1987. QCA aims to identify necessary and sufficient conditions for an outcome. So that's what you get. If you do a QCA, at the end, you will be able to say whether there are any necessary conditions for the phenomenon you're trying to explain, or whether there are not. And you'll be able to say whether there are sufficient conditions that bring about the outcome you're interested in. This could be individual conditions or combinations of conditions. Typically, we speak about combinations of conditions. And interestingly, also, often it's about different paths. So there could be multiple paths, multiple combinations that all lead to the same outcome. QCA is a systematic approach. It conducts the comparison by using truth tables and logical minimization. And what that is and what it means, I'll explain in a minute. First, one question could be, why should I bother about using QCA? What are the strengths of QCA? I think there are three main strengths of the method. The first is its ability to account for causal complexity. So QCA, unlike many other methods, has an inbuilt feature to analyze causal complexity, namely conjunctural causation. This is combinations of factors, two conditions together, three conditions together, or the absence of one condition with the presence of another condition. All of this would be about conjunctions. Equifinality means different paths, at least two paths that lead towards the outcome, comprising different conditions. And causal asymmetry means that we typically can't explain the outcome and the non-outcome with the same kind of explanation by simply mirroring that and saying, okay, if this leads to the outcome, then the absence of that should lead to the non-outcome. Often that's not the case. So we need to analyze the outcome and the non-outcome, the presence of the phenomenon and the non-presence separately. And that's what QCA does. That's part of the method. The second strength is that the analytical protocol enhances a systematic comparison across cases. It also allows for counterfactual reasoning. I think a big strength of QCA is that unlike other comparative methods, you really have a protocol, you have a guideline, how to do the analysis step by step, and how to score your cases and so forth, which is often then when you do smaller scale qualitative analysis, a bit more loose and less systematic. And that's a nice feature about QCA. The third strength is its flexibility. So it's really hard to say whether there is one type of QCA that is the typical way of using QCA, because usually people use QCA in quite different settings. We'll come to that in different fields with different numbers of cases, different numbers of conditions. They use different data sources, quantitative and or qualitative data. So there's a lot of flexibility in adapting QCA to whatever you're interested in and what you want to work on. On the right-hand side, we see the illustration that's from the textbook on causal complexity. So at the top, we see the two paths that lead towards the outcome. The outcome here is Y, and we see that there are two arrows that lead towards Y. One is just the condition A that's present, and then it is sufficient to bring about Y, and the other is about the combination of B and C. And at the bottom, we see the analysis of the non-outcome, and we'll come to that. That's about causal symmetry. How does QCA work? Two slides on the basics really of what QCA entails. One thing you need to know when you do QCA is the truth table. The truth table is not about some higher truth in a philosophical sense, but more about logical relations. So here we see a truth table example with two conditions. And the way QCA approaches any research design situation is to think about configurations. So when we know we have two conditions, A and B, and we try to account for the outcome Y, we think about how these can appear. They can appear together, as in the first row, A and B are both 1, are both present. The outcome also happens to be present. The second row features the condition A, but it does not feature B, but it still features the outcome. And then we have rows, or the third row, which does not feature the outcome. It doesn't feature A, but it features B. And the fourth row has a question mark on the outcome, and there are no cases. So this simply means logically it would be feasible to think about a situation where A and B are not present, but we don't have any such case. You could think about female US presidents, hasn't happened yet. So we don't know what the outcome would be if we wanted to explain any kind of phenomenon in relation to US presidents and gender, for instance. So this is a simple example of a truth table which always shows us the number of possible combinations. The formula is 2 to the power of k. That's what you see in the definition at the top. So if we have more conditions, obviously the truth table will grow quite a bit. The truth table also shows the number of cases that belong to a certain configuration. So they're clustered in a way based on their membership in a certain configuration. Here we can see there are 5 cases that feature A and B and also show the outcome. In a realistic setting, which we see a bit later, then we will also have measures of fit like consistency and PRI, which tell us something about how consistent this pattern is. But for simplicity's sake here, this is just a very basic and clear-cut truth table. We need the truth table for various reasons. It's helpful in its own regard, but it's especially helpful to do Boolean minimization. QCA is a Boolean method, and that means that we try to use the information that we have in the truth table in order to derive a solution which we can then use to account for an outcome. So we're interested in explaining under which conditions y occurs. We look at this truth table and we see that the first and the second row lead towards the outcome. Both configurations have cases and both configurations lead to the outcome y. We can write this down in Boolean notation, which you see at the bottom of the slide. And this reads A and B or A and non-B. So the tilde sign is the negation of a condition. We see that the second row had a 0 on B, so it's non-B. And both of these configurations are sufficient to bring about the outcome. So that's what we can say here verbally. A and B or A and non-B is sufficient for Y. And we can simplify this using the Boolean minimization rule, which we'll come to, because we see that it doesn't really matter whether we have B or non-B. In both settings, whenever A is present, then we also see the condition, the outcome Y. So we can simplify what we see in the first line and simply say A leads to Y. We get rid of B and non-B because it doesn't matter. In both of these settings in this research design, A is sufficient for Y. So that would be our solution in this very simple example, but the logic still holds also for more complicated examples. QCA, how's a typical QCA research cycle look like? I think it's useful to place this in relation to general research designs, and I would say QCA is not that much different from other qualitative approaches, but maybe also some quantitative studies. Usually we start with a research problem. So you need to define a research problem and then narrow that down to an implicit or explicit research question that you seek to address with your study. Usually you bring in theory to do this, sometimes in the form of explicit hypotheses, but maybe also in terms of a theoretical framework or some theoretical expectations. And then in the next stage, you select your empirical material, your cases. So we go around the circle to case selection. We decide which cases we want to examine empirically. And then we have to decide which features of the cases interest us in light of answering the research question. So we have to typically use theory in order to determine what conditions to focus on. For QCA, these are conditions. In quantitative studies, you would say variables, independent variables, but for QCA, these are conditions. Speak about that, these language differences also in a moment. And once we define these, we move to the data gathering stage, which will be the same as for any quantitative or qualitative study. You need to have data in order to do empirical research, so that's also the case for QCA. What we see here in blue, shaded in blue, starting with the calibration of sets, that's really proper QCA terrain, so to speak. So this is done with the software, and this is very specific to what QCA requires. So the first stage is to calibrate the raw data that we found into sets. We need them in order to work with QCA. Then we let the software create a truth table, what we just looked at in the previous example. And then we analyze whether we have necessary conditions. That's the first stage typically. And the second stage to analyze sufficiency, whether any combinations are sufficient to bring about the outcome. And this is an iterative process in QCA that's also quite different from other methods. It's perfectly acceptable and actually expected in QCA to go back and forth. So to start with a certain case selection, then maybe to realize that your case definition needs to be adapted and you need to define cases in a different manner. Maybe you have to go up a level or down a level, so to speak. Maybe you need to have other conditions, introduce new data, replace quantitative with qualitative data, and vice versa. So iteration is quite typical for QCA and expected. Until in the end you arrive at a substantive interpretation that makes sense to answer your research question, to address your research problem. And here there's a linkage, obviously, also to the theory. So you go back to what theory tells you, what other studies have done, what your previous research has told you, and so forth, in order to make sense of your QCA findings. This is an outline of my QCA book, and many of these chapters here we can't address in today's talk, so I will not speak about causation and causal complexity in depth, also not about QCA variance, that's chapter 8, or the criticism of QCA, which chapter 9 is devoted to. But I will focus on some of the core elements that we see here. One question that comes up with QCA is often, for what can we use it? And there are different ways to use the method. You can use it for pure description, and there's nothing wrong with that. There's an interesting article, or I think very nice article by John Gehring on mere description, where he actually tries to make the point that description is valuable in and of itself, and I would certainly subscribe to that. So we can use QCA to summarize our data, to create typologies, and that's often very informative in itself. And then you're in the descriptive side. You can also use QCA for explanation, maybe even to aim for causal explanation, which would require come with more requirements, so to speak. And then you would try to test theory or to develop theory. Often testing, developing can also go hand in hand, that you have certain arguments from the literature that you'd like to test, but you also want to introduce your own arguments, or you want to modify existing arguments, and then often 3 and 4 are somehow merged. But I think the general distinction that should be made, and you should also be clear about when you do your own QCA, is whether you're rather on the left side, description, or on the right side, explanation. And this has impact then also on how you make sense of your findings, and what kind of robustness tests you may need to do, and so forth. I mentioned cases, case selection, condition selection. Why is that important? So I also showed you a simple example of a truth table. The thing with truth tables is that when we add more conditions to our QCA design, they will grow exponentially. So we see here the first line is the simple example. We have 2 conditions, A and B, which means we have 4 truth table rows. A and B are present, they're both absent. A is present, B is present. Those are 4 truth table rows. But once we add a third condition, fourth, fifth condition, the number of logical combinations, possible logical combinations, grows exponentially. So we're already in the terrain with 3 to 5 conditions between 8 and 32 truth table rows. This does not have to be a problem in itself, but it can pose a problem, especially because, well, if you have 32 truth table rows, ideally, as an empirical researcher, you would want to have as many of those filled with empirical cases as possible. That means, well, you need to have a lot of cases, you need to have a lot of data. Maybe that's not possible to do on your own, so you need a project, a team to do this, or it's not even possible to navigate this at all. So this can pose a constraint on your research. This table suggests a minimum number of cases, which is not set in stone, but it's just as a guideline. So if you're thinking about QCA, typically I would say 12 cases is the minimum that you need to have in order to do QCA. I think there has been a published QCA study with just 9 cases, but QCA really delivers more once you're in the terrain of 20 to 30 cases. And that's kind of the typical QCA design. What matters clearly is the ratio of cases to conditions. So that's what you need to take into account. It doesn't make sense to have lots and lots of conditions and just very few cases. That's creates a research design problem also in other settings, but also in QCA terrain. In the textbook, I have some examples on QCA usage in different fields, which I just mentioned here in order to show you that there are many different variants and also different ways of using QCA. So there are examples from political geography, sociology, public policy, law, political science, environmental governance, and international relations. And you can look up these studies if you're curious to see how people have done QCA, how they've applied it. You also see the different variants of QCA on the left side. So fuzzy set QCA is the dominant variant right now. And what that means, what is fuzzy about it, I'll tell you in a moment. But there are also other variants like multi-method QCA, which combines the method then with other methods, as the name implies. Multi-value QCA, which is about categorical data. Two-step QCA combines two QCAs in one in order to reduce the number of conditions. And crisp set QCA works with a specific type of sets, namely binary scores. Let's move to QCA publications to give you a brief background on how the method has evolved. I mentioned at the outset that Charles Ragan developed the method in 1987. This was the first book. It was not called Qualitative Comparative Analysis, but this is basically where the method comes from. At the top, you see Ragan's books over the years, and he has also shifted in his approach to QCA, and he added elements to it. He introduced fuzzy sets in 2000. He introduced measures of fit in the 2006 and then 2006 article and 2008 book. And in later publications, there's always also there are new elements and aspects how he made sense of the method and evolved the method, changed the method, adapted the method. And the latest book is about analytic induction, which you could see as Ragan somewhat returning to the roots of QCA and focusing just on positive cases. So I'm not going to speak about this for reasons of time, but it's an interesting proposal. At the bottom, you see some of the existing textbooks that focus on different aspects of QCA, starting with Schneider and Wagemann, Set Theoretic Methods for the Social Sciences, which I would say is still the most comprehensive textbook. QCA with R by Adrian Duser. He's the programmer of the QCA package. And this is strictly about the QCA package and what it can do. Kawati and Kane have a very accessible introduction focusing on mixed method research and evaluation. Nina Warner, Carsten Schneider, Eva Thoman have a book on QCA using R. So there the focus is mostly on the set methods package and applying QCA in an R context. My book focuses on research design and application. So that's a bit of a different approach to introducing QCA. And Roel Ritten's book has the subtitle Learning from Cases, which shows you that he goes back to the cases and brings in maybe more of a qualitative logic than some of the other textbooks. So you already see that there's quite a landscape of work on QCA and also different perspectives on the same method. There's some related titles I would like to mention, really just briefly. You see them on the slide here. With the exception of Schneider's book, which focuses on combining QCA and case studies. So this book explicitly addresses QCA and the set methods package, but the other books are not explicitly about QCA, but they discuss at various levels the logic that is also inherent to QCA, the set theoretic logic that we see and that guides the research design. So all of these are recommended readings. Which brings me to QCA software. So in this talk, I will not give you an introduction to the software, which would take too much time. There are different options that you have. If you want to use QCA, the most widely used options are the FSQCA software, developed by Charles Ragan, has been around for quite some time, and the R packages QCA and set methods. So QCA and set methods typically used together. So if you use QCA and R, typically you work with both of them. They have different functionality and complement each other quite well. So that's the basic choice, I would say. Either use FSQCA, the software, click and point software, or you use the R packages. Personally, I prefer the R packages because you have much more functionality, but you can achieve more or less the same results also with the FSQCA software. If you're looking for a beginner-friendly R manual, I put together such a thing that you can see the link here, an R manual for QCA. This is not based on a package. It refers to the packages by Adrian Duser and Nina Warner et al. And also the ggplot2 package. But my aim was to make it really accessible for people who have never used R before. So if you go to the link, there's a PDF file, and the PDF explains how to install R, how to install the packages, and then step by step how to do a QCA analysis. And if you're interested in advanced functions, I recommend going to Dusa and Oana et al. Because they also provide much more detail then. Let's talk briefly about publication trends. So what we see here is the number of articles on the Web of Science that refer to qualitative comparative analysis. And I think it's interesting to see, first of all, how humble the beginnings were in the starting in 1987. So obviously there were not many QCA applications around, but we see an exponential increase starting in the late 2000s. And I think this has to do with the 3 textbooks that we see marked here, because they really opened up the method to a broader spectrum of users from across the social sciences. So the number of QCA studies has been steadily growing on the Web of Science, but also beyond. And this is just the trends in different categories. So international relations is more or less at the bottom, and the number was at 44 in 2020. I think now it's probably quite a bit higher. But we see that QCA is not limited to specific fields, but really is being used across the social sciences and beyond, also in some natural sciences. This is from a review article that Tobias Ide and I did was published in 2022. And then we looked at all of the studies that used QCA in the field of international relations, and tried to come up with some recommendations and some stock taking of how QCA is used in this field. And for the textbook, I also did a survey because I wanted to know basically what type of QCA people use in the different social science fields, what variant, crisp set, fuzzy set, or multi-value QCA. Here it was very clear that fuzzy set QCA has become the dominant method for contemporary QCA, so to speak. So here I looked at 120 studies that were published in the years before 2020. I think this was the cutoff. And this went as far back as 2017, 2016 or so. So it's really about recent publications, not about older QCA studies. And in terms of the median values, I looked at the number of cases that people use, conditions, and the case-condition ratio. And what we see here is that with the exception of business studies, it's really quite uniform. So regardless of whether you look at public administration or public health, sociology, usually in the range of 20 to 30 cases, 5 to 6 conditions, and so forth. So quite a uniform pattern, I would say. Qualitatively, what's nice to see about QCA is that it has now been published in many top journals across the social sciences, including the American Political Science Review, Nature Climate Change, International Studies Quarterly, International Organization, and so forth. So really, there are lots of good examples in highly ranked journals. Just looking at the International Studies Association, because this is our forum here today, I looked at QCA studies in ISA journals. And this is not a comprehensive list, but just some recent publications in Global Studies Quarterly, on climate, women, and conflict, in International Studies Quarterly, on peace building, identifying pathways to peace, in foreign policy analysis on democratic participation in the anti-Daesh coalition, and in international interactions about proxy wars. So we really see QCA being used across the board in most of the ISA journals also. Let's walk you through an empirical illustration of how QCA looks like. For this, I'm using my own study, not because it's one of the best QCA studies, but simply because I have the data, have the raw data, and also know about the process, how I arrived at this. So it's easy to speak about this one. This was published in 2020. It's open access, and there's also an appendix. And there's also replication material that you can find for this. So if you want to explore this, please feel welcome to do so. This was a fuzzy set QCA. We still need to talk about what that means, but for now, it's just an ordinary QCA study with 51 cases. These were government leaders from 29 democracies, and the outcome I tried to explain was withdrawal from a military coalition, was about the Iraq War. And I looked at 5 conditions and used quantitative and qualitative data. So the driving research question for this was, why did some democratic leaders withdraw from the Iraq War while others remained until the end of the military coalition? So the starting point from a political science perspective was Zapatero's announcement in 2004 in Spain that he was just elected. He was also a leftist prime minister, and he had promised that if he were elected, he would also withdraw the troops, Spanish troops, from the Iraq War involvement. And that's what he did right after the election. So as a political scientist, you think, okay, that's a great case, poster case. Do we see this also in other countries? And there were some studies that suggested, yeah, it's about leadership change and electoral incentives to explain such policy changes. But there was also broader literature that yielded somewhat conflicting expectations. And there had not been a study that really looked at the entirety of the Iraq War from 2003 until 2010 across all of the 29 democracies. So that's why I wanted to do this QCA. This is the timeline where we see the cases at the bottom. So here we have 2 blue lines. The top one is about US troops in Iraq, which started at around 150,000 and then moved up and down. There was also the surge at a later point in time, and then the withdrawal under Barack Obama. At the bottom, we see the non-US coalition troops in Iraq, and the blue dots indicate the time when a allied government announced that they would withdraw from Iraq. And this started with Nicaragua, New Zealand, and then Spain is the 3rd case. So this was the case that I showed you before. And we see there are many other cases, and also, if you will, there are 3 groups of cases. So on the left side, we see a larger cluster than in the center, Italy, Japan, Romania, and so forth. But we also see many countries or governments that decided to stay in Iraq until the end of the multinational force. So the question is, why did some stay so long? Why did some leave early? Under which conditions did these countries' leaders decide to withdraw? So in order to explain this, I looked at 5 factors, and I derived them from the literature, but also from my own reading of research on this field. Leadership change, leftist partisanship, this was probably the strongest expectation. And you see this in the second quote that is here on the slide, where I refer to these 2 conditions and say, my hypothesis basically was, quote, a change in the political leadership combined with leftist partisanship is a sufficient condition for early withdrawal from coalition operations. So the expectation was that if we see these 2 things together, there's a change in the leadership and it's a new leftist leader, then this together would be sufficient to bring about withdrawal. So that's the Zapatero case, if you will. Question is, are there other cases like that? And I also looked at other conditions. And I explicitly also referred, this is the first quote, that this is about combinations of conditions. So I did not expect individual conditions like fatalities or upcoming elections, low commitment, to have an independent effect and to lead to the outcome, but to have combinations that lead to coalition withdrawal. So this is a summary of the research design. I used the QCA packages in R, QCA and set methods. Some details here on the case selection, which you don't need to go into. The outcome was coded qualitatively, so I needed to examine documents, press releases, government statements, to clarify when, under which conditions government leaders said what, and whether they followed up with a withdrawal announcement. And the conditions, the 5, were mostly based on quantitative data from existing data sets, which you see referred to here. This is how the raw data looked like, just to give you an impression. So 51 cases, this is just the top 20 cases. There were also several observations for individual countries, meaning there were different leaders in power at different points in time. And then we see data on fatalities that occurred during these leaders, civilian, military fatalities from the country, so nationals of the country under the tenure of the respective leader, commitment, deployment, and so forth. And this then was calibrated into a QCA data set. What calibration is, we will talk about in a moment. But here we see that the scores have been turned into something from 0 to 1. So this was a fuzzy set QCA. 1 means full membership, for instance, in upcoming elections. That's in the second column under explanatory conditions. So we see that Albania's leader at the time had upcoming elections, for instance. And then we also see scores on the other conditions. The first step, analytical step in QCA, is then to check whether any of the conditions that are in the analysis are necessary to bring about the outcome. And for this, we have measures of fit. So you run the analysis with the software, and if you get a consistency score above 0.9, then you need to check whether coverage and relevance of necessity, here in this table that's RON, are also above 0.5. If that's the case, then you can interpret this as a necessary condition. Here we see that none of the conditions, neither the presence nor the absence of the condition, was necessary for the outcome. So that was the first finding, or if you will, a non-finding. The reviewers then asked me to do a chi-square test, which, as indicated here, is not part of the set theoretic analysis with QCA. So this is not QCA, but still the publication entails the chi-square test, because reviewers wanted to see whether there's a relationship between upcoming elections and the outcome early withdrawal. And this confirmed something that was surprising, namely that prior studies, which had expected that there was a relationship between this upcoming elections and early withdrawal, and this did not confirm these findings from prior studies. Basically, it's the other way around. So in situations where we had upcoming elections, predominantly there was no early withdrawal. So there were 31 cases of upcoming elections across the 51 leaders. 29 cases of those did not feature early withdrawal. So that was somewhat puzzling and certainly not as expected, but it's the empirical situation. The next stage in QCA, in proper QCA, is the truth table. So this is the full truth table with all of the empirical cases, which is a bit hard to read. So we just focus on the top rows. And when we do that, we see similar situation as in the example before. Now it's a bit more complicated. There are 5 conditions on the left side, L, E, P, C, F. Leadership, upcoming elections, partisanship, coalition commitment, and fatalities. The outcome, W, this was early withdrawal. And we see that essentially all of the cases in the top rows down to Hungary they show the outcome, they've shown early withdrawal, and they show different combinations of different configurations that lead towards the outcome. So this is the information that we have in the truth table. Now we would minimize this in QCA with the software, and we get a solution term. And this is how the QCA solution looked like. So essentially, there were 4 paths that lead towards early withdrawal. And we see on the left side the names of the conditions. So leadership change is one of the conditions. If there's a black circle, as in path 1, it means leadership change was present. We also see leftist partisanship was present, and upcoming elections were not present, crossed out. So path 1 describes Spain. It's a Zapatero path, so to speak. But it also describes Australia under Kevin Rudd. It describes Italy under Romano Prodi, and other cases. So we see this at the bottom where it says covered cases and uniquely covered cases in bold. This provides information about which cases belong to which path. So what this table shows us is, well, on the one hand, it confirms that there are other cases like Spain, but there are not so many cases like this. So empirically, more important are path 2 and path 3, because there are lots of cases in these paths, and we can also put a number to this. This is about coverage, raw coverage and unique coverage. And we clearly see that path 2 and path 3 feature more cases than path 1. That doesn't mean that path 1 is not important, but path 1 is just part of the story. So this is really causal complexity, which I see sometimes also as a curse, that you have a situation like this and you need to leave a lot of space to discuss it, to discuss your findings, to explain why we see some countries in path 1, others in path 2. We can talk about the fatalities which feature in path 2, for instance, or the low commitment in path 4. But then we also need to speak about path 3, where we see that 3 conditions are absent. And it's basically, when we look at the cases, old leaders that at some point in the Iraq war involvement decide to withdraw the troops. That's Koizumi in Japan, that's Rasmussen in Denmark, and others. And this required an explanation. And in the paper, I try to address this also then with a bit of a more qualitative discussion, following up on the QCA and contextualizing these findings. We can visualize the paths like this. So this is what you can do with R as well, to plot the membership in the paths against membership in the outcome. So this means that we see blue cases in the top right corner. These are typical cases. They hold high membership in our explanation, and they hold high membership in the outcome, early withdrawal. We also immediately see unaccounted cases in the top left, and this is Portugal 2 and the Dominican Republic 1. So they were not accounted for by our explanation in this study, but they showed the outcome. So that's something you need to address. And with these kinds of XY plots in QCA, which you should do if you do a fuzzy set QCA, it's recommended to provide these. You can easily see the different types of cases, whether you have typical cases, unaccounted cases, or even deviant cases. And then you can address them specifically and highlight them. So I think that's a nice feature of QCA because it makes it very transparent about how your results relate to individual cases, which with other methods sometimes is a bit hard to see. You have the findings, you have some kind of argument, but then the question is, okay, what does this apply to? And with QCA, the cases should always feature strongly. Let's move from this example to set theory and to provide you with some basics on set theory. Yeah, just to give you a bit of the rundown on this for QCA. Sets at the most basic level constitute groups of elements that share certain characteristics. So you can also use Mahoney's definition, sets as boundaries that define zones of inclusion and exclusion. So typically in the right hand side, we use Venn diagrams for this. You can see this Venn diagram with 3 sets. And this means we have 8 different zones, so to speak, with the 3 sets. Because we have different combinations of these sets. You can be straight at the center, then you're a member of all 3 sets. You can be completely outside, then you're not a member of A, B, or C, or whatever they're called. And then you can be in these other intersections. And this may be useful to describe these also in certain qualitative terms. So this set theoretic thinking defines QCA and distinguishes the method also from, for instance, a conventional statistical approach. In QCA, we try to explain a phenomenon to be explained as an outcome rather than a dependent variable. And we use conditions to do this explanation rather than independent variables. This is mostly about language. So I don't think should not be a major issue if you use dependent variable and independent variable. That's not the QCA language, and I would prefer conditions and outcome. But technically speaking, the difference is here not that big. What is more important are the differences when it comes to the numerical conversion of concepts and raw data. Because typically in statistics, you do measurement and then you use this data. With QCA, you need to calibrate it first. And that's quite different from what you do in statistics. Also, it is not about linear relationships in QCA, but about causal complexity. As we've seen in the example and also in the opening introduction. The analytical device in QCA is the truth table rather than a correlation matrix. and the results are not the net effects of individual variables, which typically in QCA interest you only to a certain degree, or you're mostly interested in the combinations. You want to explain under which conditions something happens, and you want to say something about necessary and sufficient conditions, and that's what you get in the end. What are crisp sets? I mentioned the term before. They're crisp because they're binary. So this simply means that you use a condition set or an outcome set, and it's only 1 or 0, only membership or non-membership. And this means that you make the qualitative differences between cases rather strong. Sometimes that may be perfectly fine because your concept really is binary and it's either or, and that's it. But oftentimes in social science concepts, there can be a loss of empirical information when you need to dichotomize. And often is also that the dividing line between membership and non-membership becomes overstated when you have to make a decision either in or out, and there's nothing in between. So that's why crisp sets also come with some drawbacks. And this led to the introduction of fuzzy sets. So Regan in 2000 introduced them in his 2000 book, drawing on Lord Visade's fuzzy logic and the concepts that undergird fuzzy logic. And the idea that Regan introduced was to have fuzzy sets allow for partial membership. So rather than say in or out, to say rather in or rather out. And to make sense or to introduce qualitative and quantitative differences. So when you use fuzzy set QCA, you can assign any value from 0 to 1 to your cases. And typically, or there are 3 empirical anchors that are qualitatively important. For full membership, that's a score of 1. Crossover, or the point of maximum ambiguity between membership and non-membership, is 0.5. And full non-membership, that's a 0. And we can look at some examples here. So this table provides examples, but there could be other calibration schemes that make sense in your context. So here it's symmetric, but it does not have to be symmetric. The crisp set is binary. You only have fully in and fully out. That's on the left side. But with fuzzy sets, you could have situations where you have just 4 values, 0, 0.3 for more out than in, and 0.7 for more in than out, and 1 for fully in. So you could introduce some gradations and not have these sharp divisions between 0 and 1. And you can make this more fine-grained up down to a continuous scale, which you see on the right-hand side. And then you have just decimal scores. And this can also be achieved with the software. We'll return to this in a moment. QCA uses Boolean operators for intersection, union, and complement, which you see here visualized, but we can also look at this table. And on the left side, you see the classical logical operators and, or, and not. And then there are different notational systems. They all mean the same thing. Effectively, Boolean algebra uses multiplication, addition, and negation, whereas then in set theory and propositional logic, you use different notational systems, but it means the same thing. Why is this important? It is important if you do use the software and you get results and it's written in Boolean notation. Then you need to know what this means. So that's at the point where you definitely have to know what Boolean notation means. Usually in publications, if it's an empirical application, I would say it's not necessary to provide a Boolean notation. You're welcome to do so, but it's not really required. Necessary and sufficient conditions. I talked about necessary sufficient conditions, but did not really give a definition of these terms. A necessary condition means that the condition is always present when the outcome occurs. It's often confused. So when we look at a condition that is necessary for something else to occur, we typically look for the phenomenon. We look for cases that show the thing we're interested in. And now we have the suspicion that there's something necessary, so this has to be present all the time when the outcome occurs. Then it would be necessary. If that's not the case, well, then it's probably not necessary. So We can express this formally with an arrow that runs from the outcome to the condition. X is necessary for Y. When we're talking about sufficient conditions, we turn the perspective. A sufficient condition means that whenever the condition is present, the outcome occurs. So now if we have the suspicion that something is sufficient to bring about something else, and this could be also a combination of factors, if these two things happen together, we should always see the outcome. So we will usually try to find instances where we have this condition or we have this combination of conditions to check whether it is actually true that X or the combination of A and B or X and Y is sufficient for the outcome. So it's a matter of perspective. There are also so-called Innes conditions. I'm just mentioning them here for completeness sake. You will come across this term if you're into QCA and you read QCA studies. At some point or other, you will come across Innes conditions. This goes back to Mackey's definition as an insufficient but necessary part of a condition, which is itself unnecessary but sufficient for the result. This definition is notoriously convoluted and difficult to wrap your head around, but it hopefully becomes clearer as you go through it several times and see that this describes a situation as we see here in the notation: A or B and C lead to Y. So there are two paths that lead to Y. B and C are not necessary. A also leads to Y. But B only leads to Y if it's together with C, and C only leads to Y if it's together with B. So they require each other. Both B and C are Innes conditions in this example, whereas the condition A is sufficient on its own to bring about Y. Okay, with that, let's move on to the calibration of sets. Calibration is about turning raw data, and this can be qualitative or quantitative, into calibrated data that we use for QCA. So we need numerical data in the end. And typically we start with a general concept. Then we define our condition or outcome. We define empirical anchors in the third step. And then we do the calibration or let the calibration be done with the software in the fourth step. And the first step is about turning a general concept or specifying a general concept and turning a noun to an adjective or adding an adjective. So rather than speaking about education, in QCA purposes, it makes sense to speak about highly educated person or highly educated. Because then it's clear if we have a high score of this, then we know what this person is. It's highly educated. If it's just education and we have a score, we don't know, is this high, low, medium? We don't know. So there should always be an adjective, and Gary Gertz called this the Reagan adjective rule. And we should use this in order to clearly indicate what the qualitative direction of our condition or outcome is. In step 2, we then choose how to operationalize the concept. That's relatively similar also to other empirical methods. So what to use in order to define highly educated, maybe it's years of education or educational qualifications. In the third step, we would then have to be precise about our empirical anchors. So how many years of education, what kind of educational qualifications will lead to what kind of score in the end. So we define these empirical anchors, for instance, more than 14 years of education or at least one tertiary education degree and so forth. And then in the fourth step, we assign scores on that basis. So a person that fulfills the criteria for being highly educated would get a score of 1. A person that fulfills the criteria for being rather highly educated, however we define this, would get a score of 0.7, and so forth. And then we would have a calibrated data set. We can do this with the software. So different ways to calibration. I'll also show you a qualitative approach in a moment. The easiest is probably to do it with the software if you have numerical raw data. So if you have that, all you need to define are the 3 anchors for being fully in, the crossover, and fully out. And on that basis, the software does the calibration. So In this example, you see data, raw data from the Human Development Index, and you see countries in different brackets. So the dataset included all of the countries in the world, but here we see just 4 brackets of countries. You see the raw data on the left side for 2017. At the top, Switzerland 0.944. This is not fuzzy data, but this is the raw data on the Human Development Index. And then you see different metrics. We don't need to worry about them at this stage. And we see the fuzzy set high human development on the right-hand side. So this is the calibrated condition, and this is the result of the calibration. And basically, the anchors that we see on the right-hand side, the 3 empirical anchors have been applied to the data, and on that basis, the data was transformed from the raw data to calibrated data, assigning the scores that we see here. How this is done is discussed, for instance, in the Reagan 2008 book. I'm also discussing it with illustrated examples in my textbook and other books, but it would take too much time to go through the metrics and measures about how this calibration is done with the software. What happens with calibration is what you see here. So we see the raw data on the X scale and on the X-axis, and on the Y-axis we see the calibrated fuzzy set, high human development. And here we see the points. These are all of the countries in the world that are in the data set, running more or less from Chad up to Norway and other cases. So some cases are listed here just to show you some examples. But of course, we also see many more points for all of the other cases. We also see 3 dashed vertical lines, and these are the anchors that we introduced. So 0.8 was the anchor for being fully in. Why 0.8? Because the codebook for the Human Development Index defines 0.8 as a meaningful anchor to distinguish cases that are highly developed from those that are not. So 0.8 makes sense. It's an external anchor. We didn't come up with this ourselves, but we took it from the codebook of the Human Development Index. And you may have similar information from policy institutions or from NGOs or whatever it is that you want to refer to, what you want to use as your external criterion, or whatever makes sense in your field as empirical anchors. And we have another anchor for the crossover, 0.7. This defines whether cases are rather above 0.5 in the calibrated set or below. So that makes the difference between Samoa and Iraq, for instance. What we also see is that the points where we put these anchors has an effect on the curvedness of the curve. So it flattens out at the end, at the start and at the end. And this is basically in our hands. So if we shift the anchors to the side, then we stretch the cases. If we put them next to each other, then we flatten out the top and the bottom, so to speak. So this is about how we treat what Reagan calls meaningful variation. So arguably, if you're interested in high human development across the globe, you don't really care that much about the difference between Norway and Switzerland, because qualitatively both of these cases would be highly developed cases. So probably both of them get a very high score. Cases like Norway at the top. Similarly for cases like Chad at the bottom. But then in the center, small increments matter more because they may mean more also on the ground in terms of human development. So that's what calibration does and how it transforms the data. What calibration does not do, it does not arbitrarily change the sequence. So you can never change the sequence. This stays the same. The effect of calibration is simply about the steepness of the curve that we see here. This is when you have quantitative data, but you may also have a situation where you work with qualitative information. So for instance, you did interviews or you went to the archives and tried to code a certain condition on the basis of qualitative information. This example from Held et al. Had a similar situation. So it was about defining agency slack. This was their outcome. And agency lag essentially is unobservable. This was based on principal agent theory. But what is observable are certain kinds of behavior. So one can observe when a principal sanctions undesired agent behavior that we see on the top left side, or when a principal expends additional resources to control an agent. And then for each of these behaviors, the study defined two indicators, which you see at the bottom. And basically, the qualitative documents that the study went through coded these documents by going through the documents and looking at these four indicators, whether there is an indication of a principal cutting an agent's budget. If that's the case, 1 point was assigned, and the like for the other three criteria or the other three indicators. And this information was then summarized across the international organizations. So this was about UN organizations. And we see some cases, some examples here. And different indicators were scored: hiring an agent, monitoring committee, budget cuts, staff reduction. The sum was taken on agency slack, a sum score of 3 for the first organization here, UNIDO, and on that basis, a fuzzy score was assigned. So that's, if you will, a qualitative way of using information and then assigning fuzzy scores directly to the cases. Different from the direct method of calibration, which you would use if you have already numerical raw data. You can also use Likert scales. So many people work with Likert scales and have survey data that reflects Likert scales. You can use this in order to do a calibration, as you see here. So you have to think obviously about the neutral category, which maybe you're neither in nor out, you're 0.5. But typically, analytically speaking, 0.5 is not very useful in QCA. And it's actually recommended to avoid the 0.5 because it means you assign a 0.5 to a case, means you don't know whether the case is rather inside or outside. So analytically, you don't know much about the case. You can avoid this. One way, for instance, would be if you have multiple surveys and you aggregate the scores, then you typically have average scores that are not 4, but they may be 4.2 or 3.8 or something like this. And then you don't run into the problem that you have to assign a 0.5. But you need to think about the 0.5, and this depends on your research design, obviously. How do we put everything together? So let's finish up the talk by looking at the actual set theoretic analysis. So the sequence of steps involves 6 different steps. And on the right side, you see an illustration here. Once we have a QCA, we have calibrated our data, the first step is always to do the necessary condition analysis. We check whether there are any relevant necessary conditions. Why relevant? Because there could also be conditions that are formally necessary, but trivial. So it could be that sunlight is a condition. Every case features this, or some other internet access, some other condition is always present. Then it will be necessary because your outcome will probably also only happen under the presence of this condition, but it's not relevant. So there's also a measure for that, relevance of necessity. There's also a coverage measure, and we look at all 3: consistency, coverage, and relevance. The software provides these scores for us, and we need to look at all 3 in order to determine whether we truly have a relevant necessary condition. The next step is then to create a truth table and to check which configurations in the truth table are sufficient to bring about the outcome, and whether enough rows meet our thresholds. Thresholds, I haven't talked about this. So when we look at the truth table in a real empirical setting, we will see that certain rows may feature, well, 5 cases that show the outcome, but there's also 1 case that does not show the outcome. Effectively, this means that this row would not be perfectly consistent in relation to showing the outcome. So the consistency would probably be less than 1, and we need to decide how low we go with the consistency, how low we accept the consistency to be. And typically, the conventional threshold is at least 0.75 consistency, if not more. So certainly not less, but you're free also to say you apply a higher consistency threshold. But this is something that you as a researcher determine. So in the software also you have to tell the software, this is the consistency threshold that I'm working with, or that I want to work with, that I want to apply to the data. And this will have an impact on your results. PRI is proportionate reduction in consistency. It's an additional metric. It should be at least 0.5 for certain reasons, which we can't go into today. Frequency is something you can specify. So you can, for instance, also say, if you have lots of cases, hundreds of cases, for instance, I only want rows that have at least 2 cases or at least 5 cases to have more robust findings, so to speak. So that's possible. Typically, we would be happy if we have at least 1 case in a certain configuration. The next stage is then about the solution terms. And we have 3 different solution terms, which you see here already. We come to the definition in a moment. And we should ask which solution fits best for substantive interpretation. So again, you as a researcher decide which solution to focus on, and you should give a justification why you focus on this solution and how you achieve that solution in the first place. And then once you have a solution, you need to determine whether the measures of fit at the very bottom are sufficient enough. Is the consistency high enough? The coverage high enough? The PRI good? Are there counterfactuals? Are the counterfactuals plausible, if any have been used, and so forth? Okay. The analysis of necessary conditions is the first stage. Here's again the definition that I used before. Formally, this means that the outcome is a subset of the necessary condition, and vice versa, the necessary condition is a superset of the outcome. In order to be treated as a necessary condition by convention, these conditions have to pass at least 0.9 set theoretic consistency to be considered necessary. And the coverage and relevance should be above 0.5. And then you're good, and you can say, well, you do have identified a necessary condition. The truth table analysis looks as such. So you may have a situation like this, simple design with very few cases, actually not that realistic, but nice to illustrate in one slide. Here we have a data frame with a study by Mantilla on Latin American countries with 3 conditions and an outcome. Now they're listed in the form of a data frame, so every case has 1 row. The truth table summarizes this information, as we see here, by grouping cases together that share a certain configuration or share 1 configuration. In the first row, Argentina, Brazil, and Chile are in the same configuration. They all 3 show resources, opportunity, and framing, however these have been defined, and they also show the outcome. And then we see at the bottom what are called logical remainders, the question mark cases. We had them in the very early example at the outset. It means for the rows 6, 7, and 8, we don't have any empirical cases in these configurations. Okay, so how does the analysis proceed? It focuses on those rows that show the outcome or that are consistent enough in showing the outcome. So this truth table here does not have consistency for simplicity's sake, but typically there would also be a consistency column that specifies this. The software then takes these configurations that we see here and works with them in a Boolean fashion. So we see that R and O and F, or R and O and non-F, the latter is the second row, both lead to the outcome Y. So we can write it down like this, and we can apply the Boolean minimization rule, which Reagan defined as if 2 Boolean expressions differ in only 1 causal condition, yet produce the same outcome, then the causal condition that distinguishes the 2 expressions can be considered irrelevant and can be removed to create a simpler combined expression. So that's what's happening. We know, when we go back to the truth table, that it doesn't matter whether F is present, that's the first 3 cases, Argentina, Brazil, Chile, or whether it's not present, that's Peru. When R and O are present, and that's only in the first 2 rows, then we see the outcome. So This is our solution. We can summarize the information as such and simply say R and O is sufficient to bring about Y. Resources and opportunities are sufficient for democratization support in the context of this study. Things are a bit more complicated in the software and in the minimization that happens in the software, because you may have a situation like this. What we see here with the lines from the drawing, basically from the first more complex line, which entails truth table rows, to the second line where some minimization has happened, is that certain expressions have been compared. So A and B and C and A and B and non-C have been compared. And we decided, okay, we can get rid of C, non-C. It doesn't matter, C, non-C, A and B are the same. So we simply keep A and B and we get rid of C and non-C. And we do the same thing for the other expressions that we see here. And then we could arrive at something like A and B, or B and C, or non-A and C. Now the question could be, can this be further minimized? It cannot, with the rule that we learned about, the Boolean minimization rule, because they're too different. So it's not possible to minimize further, but it can be with the so-called prime implicant chart. This happens inside the software. So most of the time you don't need to worry about it, but you should know about it, and you should be able to check the prime implicant chart in certain empirical situations. So what happens there is that the software writes down the primitive expressions. These are the truth table rows that are associated with the outcome. So at the top we see our 4 rows, A and B and C, A and B and non-C, non-A and B and C, non-A, non-B and C. That's what we had in the truth table. Then we see what we arrived at through Boolean minimization. And these are called the prime implicants. A and B, B and C, non-A and C. And now the chart simply shows us which primitive expressions are covered by which prime implicants. And we see that the first one covers the first 2 expressions, and the last one covers the third and the fourth expression. So B and C, the second prime implicant, is not necessary. It's redundant. We can get rid of this and simply use A and B and non-A and C to cover all of the empirical information that we have. So this would be our solution, A and B or non-A and C. And that's what happens inside the software. In FSQCA, sometimes you need to solve the prime implicant chart, and that's when you need to know what is happening there, which is what we basically just went through. Once you do this, you get 3 solutions with QCA: the conservative solution, the parsimonious solution, and the intermediate solution. The conservative solution is the result of the minimization process based on our specified consistency and frequency thresholds. And it's called conservative because it works solely with our empirical cases. It does not incorporate logical remainders, those are the question mark cases, to achieve further simplification. That's what you get. Often it's also the most complex solution. It cannot be more complex than this for logical reasons. That's kind of the drawback of the conservative solution, one drawback. The parsimonious solution results from the minimization, the same criteria, but additionally, the algorithm in the computer is allowed to consider all logical remainders in the pairwise minimization. And those that are used are called simplifying assumptions, and they're used to achieve further minimization. So you get, as the name implies, a more parsimonious solution. The problem is this could rest on untenable assumptions because it uses implausible counterfactuals. That's a problem of the parsimonious solution, or a potential risk. The last is the intermediate solution, where we consciously say or tell the software how to engage with logical remainder rows to achieve further minimization. And this is typically between the other 2 solutions. So here we see an example with real data, how a conservative solution could look like. A different notational system. We see there are 3 paths, 1, 2, 3. And the first path is A, non-B, and C, or that's why we see this relation column, second path, non-A and B and C, or third path, A and B and non-C, and they all lead to Y. So that's the conservative solution. We also see scores on consistency, PRI, and what is called raw coverage and unique coverage. This is about how much of our empirical material is accounted for. At the top, you see 0.87. This is for the solution as a whole. And then we also see coverage for the respective paths. You can see from the table that the intermediate solution and the parsimonious solution are both simpler than the conservative solution, but they rest on assumptions. And that's what you need to know, and these assumptions need to make sense. It would probably go a bit too far to also talk about the treatment of logical remainders, but yeah, be aware of this, and you can read up on how this is done, what the guidelines on this are. We can visualize the three solutions, and yeah, I often think of it in terms of how bold you want to make an argument. So on the right-hand side, you see a parsimonious solution, which is relatively straightforward. So it's A and C or B that explains your outcome. And on the left side, you see a conservative solution, which is much more specific. So it doesn't speak about B alone, but it speaks about B in combination with non-A and C, or B with A and non-C. And this is more fine-grained and more specific. And this is strictly based on the empirical cases. It may be that there's a redundant condition there that the intermediate or the parsimonious solution don't have any longer. So that's an advantage of the intermediate and the parsimonious one. But those need to make sure that they don't work with implausible remainders. Some guidelines to wrap this part up, and then we're almost done with the presentation. So whenever you do QCA, the first step in the set theoretic analysis should entail the testing for necessary conditions, including their relevance if you identify any conditions that are necessary. You have researcher input when you do the truth table analysis, and you should consciously make decisions about consistency, frequency, treatment of logical remainders. When you derive the solution types, they should all be documented, but you typically emphasize one of them. So you need to make a decision which solution to focus on for your empirical study in your article, and maybe document the others in the appendix or a supplementary document. When you use logical remainders for the intermediate or for the parsimonious solution, attention should be paid to only include plausible counterfactuals. And for the substantive interpretation, it always makes sense to return to the cases and often to re-examine the truth table to check where are cases that you know about whether they showed the outcome, did not show the outcome, about qualitative criteria, in order to interpret this in that light and discuss these cases in light of your solution. To wrap up, one slide on the strengths and limitations of QCA. So as I mentioned at the outset, one big strength of QCA is that the method can account for causal complexity. In order to make the most of this, you should also incorporate this in your theory. So to formulate theoretical expectations in terms of causal complexity, configurations, equifinality, different paths towards the outcome, and the fourth. That's for the theory. That's also to justify why you want to use QCA. Another strength is that it allows for a systematic comparison across empirical cases and counterfactual reasoning. This means the emphasis should be placed on the truth table, conscious treatment of logical remainders, and substantive interpretation of the solution paths. And the flexibility is an asset. Use it by using the most suitable QCA research design and the best variant for your research problem, and adapt the analytical routine in a way that makes sense for your research problem, obviously. There are limitations to QCA. There's a chapter on criticism of QCA in my textbook, if you want to go into this. One limitation is that the QCA is sensitive to changes in calibration and, in the case condition, selection, obviously. So this means we need to thoroughly justify why we include certain conditions, why we include certain cases, how we arrived at these, how we calibrated our conditions and outcome, and what would have happened if we had chosen different anchors, and so forth. There are also robustness procedures, and R packages that do this and help us with that, and they can be used to provide more transparency about this. Another limitation is that you simply need a certain number of cases. So I would say if you have less than 12 cases, then it's very difficult. It will be very difficult to do a QCA. So you need to find a way to adjust your case condition ratio that you have at least 12 cases, and then also certainly fewer conditions than cases. You can look at the table with the case condition ratio as some guideline on that. If you have too many conditions, it will also not work. It will also give you very complex solutions, and will be very hard to interpret. Finally, the one limitation is that QCA's comparison is inherently static. So whatever you put into a QCA is treated in the same manner. QCA does not distinguish whether something happened first or something else happened later. You can include this in your research design in the way you assign scores or in the way you measure certain things. So it's possible to integrate time in your research design, and there are also some examples in the book. But in itself, QCA does not allow for any distinction there unless you use a variant like TQCA, which has not been used that much anymore. But there's development in this area to also incorporate time, but so far I think there are very few empirical applications. Guiding principles. When you use QCA, aim for suitability, parsimony, and transparency. Suitability obviously means that simply you use QCA on something where QCA is suitable and not on a problem where another method may be better suited. Parsimony does not mean that we have to go for the parsimonious solution or the most parsimonious way of doing things. But generally, I think in research design, it makes sense to strive for parsimony and conciseness, because with QCA you already have a lot of complexity, and it makes sense to limit the number of conditions to a feasible minimum. You will be rewarded later when you do your interpretation. So that's one thing I would clearly recommend. Transparency is key. Many decisions need to be made. You need to be transparent about what analytical decisions you made, and to document your steps in publications. Also to provide, ideally, your raw data, calibrated data, and R scripts. Many QCA studies nowadays do this. This is good practice, and they provide this in repositories where you can find then this kind of information. Okay, with that, I think we're more or less in time. Thank you for listening. I hope it was easy to follow. You find my contact information here, so my email is there, and also my website for more information. There's also a link to the Harvard Dataverse on my website where you can find replication scripts for some QCA studies. So please feel free to reach out to me if you have questions later. But I'm also happy now to address some of the questions that have been asked in the Q&A. If you have more questions, please feel free to add them. I'm looking at that right now. I see that there are 4 questions, so I'll look at them in a moment. But if you have other questions, then please feel free to write them down. So the first question, I'll read them out. Maybe that's then easiest. Is it possible to incorporate time into QCA? My cases are not exactly observations, but rather events. For example, the Arab Spring and civil war in Libya from 2011 to 2020, authoritarian backsliding and Euromaidan in Ukraine, 2010 to 2013. Is there a variant of QCA that captures this temporal dimension in the assignment of values, or should I rely on the simple arithmetic mean? Thank you. Yeah, thanks for the question. I briefly addressed time just now. I would say, if I understand you correctly, this is about the casing, right? The definition of what your cases are. And if you say you have the Libya case, and this runs from 2011 to 2020, this of course is a relatively long time period. I would look at it in a way ask whether it makes sense to divide this into different periods qualitatively, not necessarily year by year. I mean, that may not make sense. Maybe that 2011, 2012 is kind of the same, but then later periods are more important. So I would look at it qualitatively and ask, are there important critical junctures, for instance, that divide the first period from a second and a third period? If so, maybe you turn Libya into 3 cases that then probably also show different values on the condition and the outcome, I would assume. And thereby you could integrate time. So I think for me, it's a research design question. How to answer that really would very much depend on the context and the kind of question that you're asking. Yeah, I would be open to split these cases up qualitatively into different episodes, which would have also the benefit that you then have more cases, if that makes sense in this context. Okay, I will go to the next question. Okay, this question was about the calibration, I think. To clarify, level of development is based on education years using HDI data. So actually, yeah, good point. So I mean, this is based on the raw data in the Human Development Index. So I think, I mean, there was one example about education, and then there was an example about development. This here draws on the raw data from the Human Development Index. The next question, is there any rule for determining the appropriate variant of QCA based on the number of cases? Okay. No. There's certainly not a rule to determine the variant. And I think the number of cases really has any impact on the variant. Sometimes people sympathize with two-step QCA if they have many conditions. So sometimes I've not talked about two-step QCA, but in the book this is introduced. You can also go to Schneider and Wagemann's 2006 article about two-step QCA, and there are some later developments on this. This is often chosen when people have lots of conditions and can't really reduce the number of conditions and then want to distinguish between remote and proximate conditions and do one QCA with the remote conditions and then another one with identified remote conditions that are relevant contexts together with proximate conditions. This could be useful, but you could also do an ordinary QCA in the same circumstances and try to limit the number of conditions. So there's not necessarily a link between the variant and the number of cases. Okay, another question. Okay. Finds the session useful. I'm glad to hear this. Okay. At my institution, we have to register the title of the project, but cannot be changed later. I was doing a preliminary literature review of studies and noticed that they use different configurational terms, including configurations, patterns, archetypes. I was wondering if you have any advice regarding how we can decide on which term to use, and what could this decision depend on in the context of organizational research? Okay. If I understand this correctly, then it's about whether to speak about configurations, patterns, archetypes, maybe recipes, pathways. I would say, configurations is the technical term. That you have configurations in the truth table, like different configurations in each row that describe certain cases. I think in terms of empirical settings, it often makes sense to speak about recipes or paths or pathways. I find this more intuitive. It depends on the project and the empirical situation you're speaking to, whether it makes sense to speak of paths, which kind of has this trajectory idea, whereas a recipe is a different kind of image. But I think this is completely up to you. Patterns often works well. And all of this would obviously also work with QCA. So if you use patterns, you can use QCA. If you speak about configurations, hopefully then this does not box you into anything. So simply select what is most appealing in your context, I would say. Okay, another question. Linguistic question regarding the Eines condition definition. I know it by heart, but it always confuses me why it says a part of condition. Yes, instead of part of configuration. How can an Eines condition be a part of a condition? As we can see in the example you provided, it seems to be part of a configuration. Yeah, thank you, Anna. You're completely right. So this is the quote of John Mackey's definition, where he uses the term condition for what we would call a configuration in QCA. That's right. Um, so maybe it would even make sense to directly use an adapted definition of Eines, and then mention in a footnote why this refers to a configuration rather than a condition, because then that at least that part of the confusion could be solved. So I agree entirely. Configuration instead of condition would make a lot of. Okay, another question. Does robustness analysis, similar to sensitivity analysis, trying changing the anchor values of calibration and repeating the analysis? Okay, so the question is about robustness as far as I see it. Yes, so I used to have one slide about robustness. I took this out because I wanted to cut it down to 90 minutes. Maybe I should have kept this. Um, you can define robustness in different ways. Essentially, I would say it's about uh, checking to which extent your results are dependent upon certain analytical decisions that you make and whether the results would change if you would have changed certain analytical decisions, including your calibration. And with the calibration, it's the easiest that you can, yeah, basically do a sensitivity analysis and check if you set the threshold higher or lower, would this change the result? And at which point would it change the result? And then you can report this, and the set methods package now has an additional function that Nina Wada and Carsten Schneider introduced, where you can provide exactly that, and provide sensitivity ranges for your calibration and also some robustness measures for quantitative sorts of calibration decisions. It does not solve the issue that, I mean, in the end, at the end of a robustness test, there's still the question, how robust should it be? I mean, it's not surprising that if we change decisions, this would also have an effect on the results. So I would not be too worried about this, but of course you need to address this and speak about this and say, okay, so we chose this threshold. If we had chosen a substantially higher threshold, this would have changed the results, but this is why we think our threshold really makes a lot of sense. So that's not solved with a quantitative test, but you can provide the quantitative test and the results and then discuss this, obviously. Okay, another question. Can QCA be appropriate for one country case study? What would be the challenges? Well, one country maybe, but you need to have more cases. So certainly you could say, well, you look at a country, but then you look at different governments over time, and then maybe you have lots of governments over time, or you look at different municipalities in that country, but you need to go into the direction of at least 12 different cases, I would say. Another question. Presentation was easy to follow. Thank you. Okay, oops, it's jumping. Okay, I'm ready to select cases and think about conditions. What would you recommend as a best next step for me in terms of expanding my understanding and preparing to apply the method? Okay, I think I'm not sure if this is answering the question, but I typically, when I'm thinking about a new QCA project or about others QCA projects and trying to advise on this, I would like to see one example of the phenomenon you're interested in. So, okay, you have this research problem that you want to address. You have this question. You have one case, maybe a typical case, poster case. We say, this is where we see this happening. We see a configuration, this leads to the outcome. Describe this case, and then from there, or by looking closely at that case, you typically learn a lot already about what potential conditions should be in there, what could explain something, what puzzles are there, and then you move to other cases. are there other cases like that? Are there cases that don't show the outcome, but they should have shown the outcome? And then you build this until you're at the stage of a QCA design, I would say. Another question, is it possible to replicate any existing quantitative statistical analysis using QCA if we have the raw data? First question. Second question, is QCA applicable to large N? Okay, I don't think it's possible to replicate a statistical analysis with QCA because they do different things. If there is a quantitative study and they've shown that some factor was significant for something else, and you have the data, you could use this data and calibrate this in a meaningful way for QCA and then run a QCA using this data. You need more conditions. So maybe it's possible to model a QCA on the same kind of context. It would still be a different study. And you could look, for instance, at Barbara Fiss' article where she looked into regression analysis, compared regression analysis with QCA. Maybe that gives you some ideas about how it would make sense or whether it would make sense to do these kinds of studies. The second question, yes, QCA can be easily applied to large N, so that's not a problem. And people have done this. So there are QCA studies with hundreds of cases. One challenge is that obviously it's more difficult to speak to the cases because if you have hundreds of observations, then typically maybe you did not gather the data yourself. You don't know much more about the cases than what you have in terms of data. So this kind of aspect is then downplayed. And it may also be because it's large N that things become more messy. You know less about it. The noise will increase. So it's not really the strongest suit of QCA, I would say. I mean, there are exceptions. There are some good QCA studies that work quite well with large N, with dozens or 50, 60 cases, hundreds of cases. But most QCA studies are really in the range of 20 to 30 cases. Okay, another question. How can we study Israel as a case of security, especially when the dynamics are not constant, in a sense that the decisions taken to protect the state varies accordingly? I look for suggestions to how approach and analyze the situation. This sounds like, yeah, something interesting, but not necessarily QCA related. I don't know what the background to this is or how you would want to study Israel here in this context, and whether you see this as one case or several cases over different governments over time or certain policy decisions. I don't know what. So that would be what I would need to know in order to advise on this. But I mean, also feel free to send me an email, let me know what you have in mind. I think this is the final question. Could you speak a little more about how one case might be split into several, i.e., an example of how you have seen that done and the reason why it worked? Nice. Yeah, thank you, Aaron, for this question. I could speak about the example that I had in the empirical illustration. So I can go back there maybe or not. I'm not going to go back there. So this is about the empirical example that I talked about the withdrawal from the Iraq War. And when I started this study, actually, I wanted to compare the 29 democracies that were involved in Iraq. And then I realized, okay, this is from 2003 until 2010, and we have lots of government changes in between. Probably doesn't really make sense to aggregate this and say this is Spain or this is the UK. Maybe more for Spain because Spain stayed from 2003 until 2004 and then they left. But there were two governments already involved. That's basically meant it made more sense to disaggregate this and to look at this at the government level. And this unfortunately also meant that I needed to change the entire research design because some of the conditions that I had in there before didn't make sense when you look at the leader level. So at the leader level, of course, then you need to take data that actually reflects the tenure of that respective leader. So you need to have fine-grained data that is actually, from whatever, March 2007 until February 2009, which was the tenure of one specific leader. And this created a complication. And for instance, for fatality data, this needed to be precise by the date in order to associate it with a certain leader. And before that, I worked at the country level of the entire period of time, was in that sense much easier. But then also some questions like the leadership partisanship wouldn't have made sense if I look at the country as a whole, because there were different leaders. But as soon as I look at the leader level, then I can introduce also leader level characteristics. So that's what I did to some extent. And I think that's often useful. I mean, it takes a lot of work, but if you're at a point where you're a bit stuck with your QCA research design and you're not sure how to increase the number of cases, or why you find inconsistent results, or why you somehow can't address this problem, maybe it's about how you define the case. Maybe you need to aggregate the cases, or you disaggregate the cases, and move down the ladder of abstraction, so to speak. And by changing what your case is, then also achieve more leverage on your research problem. Okay, I think this was the last question. I thank you all for your interest in this, and please don't hesitate to reach out if you have questions about QCA at any point. You have my email and my website, yeah, I look forward to hearing from you. Thank you so much.
Thank you so much, Patrick, and thank you everyone for attending. Have a great rest of your day.
Thanks. Bye bye.